Welcome! After last lecture, finally we have our 2D clouds ready, and they work for both of the daytime and nighttime. If I change my time of day to nighttime, and this is what I get. And the end result actually looks quite promising. And in some cases, maybe this is all we need for our sky. Now with our 2D clouds ready, next type of clouds that I'm going to add in is the volumetric clouds. And before we do that, there's one important material concept that we need to go over. It's also something that we'll use over and over again throughout the course. For that, I'm going to go back to my examples map. So go back to this test maps, double click to open this examples map. Click Save Selected. Inside of this map, I'm going to duplicate another one of this cube. So select it and hold down Alt on my keyboard and drag it out. First, I'm going to reset the material. Then I'm going to go back to my examples folder, then create a new folder. I'm going to call this one Planar Projection and double click to open it. Just to make a comparison, I'm first going to create a default material. So right mouse button click and select material. I'm going to call this one m_default projection and double click to open it. Inside of this material, I'm going to hold down T on my keyboard to bring out a texture sample node. And for the texture here, I'm going to use the same texture. So it'll be UE4_logo. Then hold down U on my keyboard to bring out a texture coordinate node, plug this into UV, and plug the RGB into base color. There's nothing complicated about this one. This is something that we've been using the whole time. Go back to my level, I'm going to first drag out a plane. So scroll down, drag out this plane, and move it up a bit. I'm going to increase its size, so change its scale to something like 5. And I'm going to assign this material to the plane. So having the material selected, I'm going to click this icon, and this is what we get. So this is the default projection using texture coordinate. Now let's look at how we can use planar projection. For that, I'm going to duplicate this material. So select it, press Ctrl+D. I'm going to change its name to planar projection and double click to open it. Now for this texture sample, instead of using the texture coordinate node, we'll need to use the node world position. So this node here will output the world position of every pixel from the mesh, and we can use the data it provides as the new UV for this texture sample now. And traditionally, we'll need to use a component mask. So I'm going to press Shift+C to bring out a component mask, and I'm going to plug this XYZ into this socket. In my component mask, I have the red channel and green channel ticked, so that means I want to use the X and Y as the UV of this texture sample now. And if I plug this into the UV socket, you can see this is what I get. And because this is so commonly used, a new socket has been added to this node after 5.2. So you can see we also have this socket that says XY. So this is the same as plugging into this pin into here. You can see we get the exact same result. So I'm going to click Apply and go back to my level. I'm going to duplicate this mesh. Then I'm going to assign this mesh this material. So click this icon, and you can see this is what we get. The end result here looks like we've broken the projection, but if we look closely, we can actually see the pattern of this texture. It just becomes too tiny to see, but it's still there. So what does this mean, and how is this any useful to us? To understand planar projection, we'll need to start from this default projection. So you already know that for this default projection, we are using the texture coordinate node as the UV, and this is the end result we get. And I'm sure you already understand the meaning of this texture coordinate. And for our planar projection, this is our end result. And the UV that we use to project this texture has now become something like this. So imagine this is the mesh that we just assigned our material to, and we are viewing this mesh from top view. In case you forget, the world position now outputs the world position of every pixel from the mesh. For simplicity's sake, I'm going to say the pixel at the top left corner is at our world origin. Since we're only using its X and Y, that means they both have a value of 0. And I'm going to say this is a super large mesh. For this pixel at the top right corner, I'm going to say is 8000 for the X and 0 for the Y. Since this is a square, same thing goes for this vertical axis, so you'll be 0, 8000 for the XY. And for the bottom right corner, you'll be 8000 and 8000. And this is actually our texture coordinate that we use to project this texture. That means from 0 to 1, we should see one pattern projected, And in Unreal, 1 unit means 1 centimeter. So for every 1 centimeter, we'll see 1 pattern projected. And that's what we are seeing here. The pattern becomes really small, and apparently this is not something we can use. And to turn this into something that we can use, this is the math that we can do. So take this horizontal axis for example. I'm going to call U in here. For the value on our U axis, we already know it ranges from 0 to 8,000. So now I divide our U by 200 and the end result that I'm going to get. So from 0 to 200, the value now will become 0 to 1. And from 201 to 8,000, the value will be greater than 1. So now from 0 to 200, I should see 1 pattern projected, and our pattern should become much larger. And the number I'm dividing here becomes the scale of our pattern. So now I change this to 400. So now from 0 to 400, the value should be 0 to 1. And our pattern should become much larger. And that's the idea of planar projection. Since we're only using X and Y to project our texture, we can also call it XY plane projection. Back to my project. Now we already know how to fix this. I'm going to go back to my material. I'm going to move this component mask up, and I'm going to drag out this pin. I'm going to divide it by a value. So I'm going to change this to 200, and I'm going to plug this into UVs. Now if I click apply, and you can see this is what I get. So from 0 to 200, we have 1 pattern projected, and the pattern itself just became much larger. So now if I change this to 400, and click apply, and we have a much larger one. Now you must be wondering, why would we want to use the method on the right and not the one on the left, since the end results here look quite similar, and that'll be our mini challenge today. So your challenge is, same as I did, I'd like you to create 2 materials in your example map. One uses texture coordinate node and another one uses word projection. And you can use a divide node to control the scale of your projected pattern. After that, I'd like you to assign them to 2 different planes in your scene. Then I'd like you to figure out what's the difference between these 2 methods. You can try scaling them or moving them or rotating them. Pause the video now and give this a go. Or come back if you need help. Welcome back. How did that go for you? Now let's figure it out together. So for the mesh on the left, this is using texture coordinate node. Now if I rotate this mesh, you can see the pattern rotates with it. And if I scale down this mesh, you can see how the pattern is affected by it. And if I move it, the pattern moves with it as well. And for this one, so if I rotate it, you can see the pattern is unaffected, and same thing goes for scaling. And same thing goes for moving. So when we are moving this mesh, it appears that we are moving through the texture. And that's what planar projection means. We are projecting this texture onto the XY plane of our world, and therefore it is unaffected by the mesh. And this is going to become super useful when we want to project something onto our world uniformly and not affected by the mesh. For example, things like our volumetric cloud, or puddles, or a landscape layer. So this is the technique that we'll use over and over again throughout the course. But there's one downside of this technique that you must know. So I'm going to delete these 2 planes. And to quickly show you what that is, I'm going to drag in a cube. So drag out a cube, and I'm going to increase its size a bit. So to something like 3. And move it up a bit. So for the first one, I'm going to assign this material. So this default projection. And this is what we get. I'm going to duplicate this cube. I'm going to assign it this planar projection, and you can see this is what we get. In order for us to see this better, I'm going to change its scale. So from 400 to 200, and click apply. Now go back to my level. You can see this is what we get. If we are viewing our cube from our z-axis, our projection is working. But if we look at our cube from y or x-axis, you can see the pattern gets really stretched. And that's the downside of this planar projection. I'm going to go back to this material. Just to make it clearer, I'm going to use this pin instead. So I'm going to plug this pin into this divide node. So for projecting the texture, we are using the X and Y. And the axis that we don't take is the axis we are projecting this texture on. And there are many different names for this technique. Besides planar projection, you can also call it world position projection or world Z projection. So if I change my preview mesh to cube, So this projection only works when we look at the mesh from top down. Alright, I'm going to click apply and go back to my level. So I'm going to drag in to text render actor. I'm going to select this one and hold down Alt to duplicate it. And I'm going to lower its size down a bit to something like 70. And I'm going to change its content to default projection. And this is this cube. And I'm going to duplicate this text again. So this one here, this is word Z projection. And I'm going to duplicate this text render actor again. And I'm going to change its content to word X projection. And duplicate this one again. I'm going to change this one to word Y projection. And I'm going to duplicate this cube twice. So this is for word X and this is for word Y. I'm going to reset their materials. So now we already know how to create this word Z projection. And for our word X and word Y is actually something very similar. And that will be our challenge today. So our challenge is, same as I did, I'd like you to drag in 3 cubes to your example map. Then I'd like you to create 3 different materials for projecting our texture. And the method that I'd like you to use would be word Z projection, word X projection, and word Y projection. Remember, the axis that we don't take is the axis that we project our texture on. Pause the video now and give this a go, or come back if you need help. Welcome back. How did that go for you? Don't worry if you ran into any issues. Let's look at how it can be done. So we already have our word Z projection. I'm going to change this name from Planar Projection to M_word Z projection. And next, I'm going to create this word X projection. So I'm going to duplicate this material and change the letter from Z to X. Then double click to open it and go to this word position node. So now, instead of masking out the first 2 values, I'm going to mask out the G and B channel and untick this R channel. Now we are projecting our texture on the X-axis, or you can call it the YZ plane. If I click apply and go back to my level, now if I assign this material to this cube, and this is the end result that I get. So this projection only works if we look at the cube from the X-axis, and if we try to look at it from Y or Z axis, we'll get some really stretched patterns. Alright, that's word X projection, and I'm going to create the word Y. So duplicate this material again, change the letter from X to Y, and double click to open it. So now, instead of masking out the green and blue channel, we'll need to mask out the R and B channel. And if I click apply and assign this material to this cube, now if we look at our cube from Y axis, we'll get working projection. But if we look at it from X or Z, we get some really stretched patterns. And that's our word Y projection, as simple as that. Now you must be wondering, is there a way for us to project the texture on all 3 axes? And the answer is yes. That's where the name triplanar projection comes from. And we'll look at how we can do that later in the course. Now with this out of the way, starting from next lecture, we are going to look at how we can use what we've just learned to create volumetric clouds. So these are my final notes in those 3 example materials. So the first one is the X projection, the second one is the Y projection, and the third one is the Z projection. If you don't like the term word Z projection, you can also call it XY plane projection. As long as you understand how this works, it doesn't really matter how you call it. I'll see you in the next lecture.